Okay, continue on question number 15. You've got this here. Now, you want to solve this, you want to find the x values. You're given a bracket and you're squaring it. Let's just go and expand the bracket. That sounds pretty sensible to me. So we've got x to the power of 1 over 2. Take away x to the power of 3 over 2. And you're going to be timesing it by itself, so something looking a little bit like this. Okay, and you're going to be doing your FOIL. Now, if we go and do x to the half times by x to the half, you're timesing with the same base, you add the powers, so half and half is going to give you 1, so x to the power of 1, which is just x. You then go and do x to the half by minus x to the power of 3 over 2, and a half add 1.5 is 2, so that will give you minus x squared. You've then got x to the 3 over 2, negative times by x to the half, add the powers, again you get minus x to the power of 2. And then finally, you've got timesing two negatives, which will give you a plus. 1.5 of 1.5 is going to give you x to the power of 3. So that just simplifies down to x cubed, and then minus 2x squared plus x. So we now go and say you've got this, so x cubed minus 2x squared plus x is equal to x squared plus x. So I've gone and put the left-hand side, this part here, equal to the right-hand side. Now, there should be some cancellation here, hopefully, maybe. Yeah, there's a little bit. This will go with this. And I can go and take away the x squared onto this side to give me the following. X cubed, take away 3x squared is equal to 0. Now let's go and factorize out an x squared. So x squared bracket x take away 3 equals to 0. So therefore x squared must be 0. So therefore x would be equal to 0. And you got x take away 3 would be 0. So x is 3. So you've got two solutions here. You've got x is 0 and you've got x is 3. Okay, so that should be the solutions. Question 15. X is 0, x is 3. Good. Question 16 looks like the binomial expansion. You've got the expansion of this and this here have the same x squared coefficient. Work out the value of a. Now, to understand this, we've got to go and consider Pascal's triangle, which is this stuff over here. Okay, and we're going to have to go up to the power of 4. So you've got row 0, which is just 1. You've then got 1, 1. You've got 1, 2, 1. You're adding numbers together. 1, 3, 3, 1, and then 1, 4, 6, 4, 1. Now the way that this works, if you're not familiar, is you just add the two previous parts, give you the middle part. So like 1 and 2 gives you 3, 2 and 1 gives you 3, and it's always 1 on the outside. 1 and 3 gives you 4, 3 and 3 gives you 6, 3 and 1 gives you 4, so on and so forth. Where the first bit is row 0, so that's going to be row 0, row 1, row 2, row 3, and row 4. I've done the first 4 rows because the first expansion has got a power of 4 in it, which is this one down here, row 4. And you've got a power of 3, which is the third row. Now if I look at the first bracket here, you've got 1 plus 12, x to the power of 4. Now you only want where the coefficient, the power, is x squared. So whenever you do this, right, there's always going to be kind of 3 parts to it. But you only want where the power is going to be 2. Now, when this is going to be square, okay, you need to bear in mind, so the first part a here is 1. The first part is when it's going to be 1 to the power of 4, okay, or in other words, when x would be power of 0, and then x increases by 1, so x would be 0, x would be 1, x would be 2. So you want this part of it. So your coefficient is going to be the 6 going in over here. Oh, what's happened there? How have I done that? How have I done that? There we go. So the coefficient is going to be 6 going in there. Now, on this spot here, so you go 1 to the power of 4, and then 3, and then 2. So it's going to be 1 squared going in here. And then you've got your b part, which is 12x. And that's also going to be, because x starts at 0, 1, 2. That's also going to be to the power of 2. Now, if you're not familiar with the binomial expansion, this might be a bit confusing, but basically, right, these powers here always add to give you the power in the question, which is 4. 2 and 2 gives you 4. And the reason I've kind of done this, because the first part, the 1 will be 1 to the power of 4, the 1 to the power of 3, the 1 to the power of 2. Okay, and then this goes from 0, and you count upwards, so it'll go x to the 0, x to the 1, x to the 2. Now, if you kind of simplify this, that's going to go to 6 times by 1 squared, which is 1, times by 12x squared, which is 144x squared. So 6 by 144 is going to give you 720 add 144 is 864, I think, so 864x squared. I'll do something similar with the other part, which is a plus 4x to the power of 3. And again, you only want the particular square term in it, so let's give ourselves a bit more room actually. So it's really laggy, really laggy. So you want a plus 4x and then cubed, where you want the 3 terms here. This time you're looking at the power of 3, so you want the third row here. Okay, and when x is a square, okay, because that's your second term, you're going to start off with x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3. Sorry, you want x to be square, so it's going to go x0, x to the power of 1, x to the power of 2. So it's going to be coefficient of 3. So it's going to be 3. The second part is going to be 4x power of 2, which means that the a must be to the power of 1, because 1 add 2 gives you 3. Well, that's going to simplify to give you 3 times by a times by 4x squared, which is going to be times by 16x squared, which will give you 48 48ax squared. So now what you're really saying is the coefficients before x squared, so this part and this part from the question, these are the same. So you go and put them equal to each other. You go and say you've got 48a being equal to 864. So you go and divide through by 48. Now if you go and do this, if you're not sure how to do this, just keep dividing through by 2. So 432 over 24 over 216 over 12, which is 108 over 6, which is 54 over 3, which is 18, isn't it? 54 divided by 3 gives you 18. And that should be the answer to question 16, sorry. 16 should be 18. Good, it is. Question 17 is as follows. This curve here has a stationary point at the point -2, 11. Work out the values of a and b. So stationary point means you want to take the derivative, and the derivative at a stationary point, dy by dx, is going to be equal to 0. So stationary point is where the rate of change, the gradient, is 0. So something like this or something like this. Basically, just go and differentiate what you've got. So dy by dx is equal to 3ax squared plus 2bx, and then the 7 will go to nothing. Now, you know when the x coordinate is -2 and you put that into this, the rate of change is 0. Okay, so now you can go and say the following. So when x is -2, 3 times by a minus 2 squared plus 2b by -2 is going to be equal to 0. So it's going to give you 4 times 3, which is 12a, minus 4b is equal to 0. Now I can see here it's going to be simultaneous equations, because what you've got here is you've got two unknowns, a and b, which you want to find. So that's one equation, which is fine. I've got to get a second equation, and I can do that as follows, because I can actually just go and put in the x and the y values into the equation to get myself a second equation. Okay, because this coordinate lies on the line. Yeah, it's a stationary point, so that point will be somewhere down here or up here somewhere. It lies on the line, so I can put it into my equation to give me, let's go and do it in blue. So y is equal to 11 is equal to a times by -2 cubed plus b times by -2 squared plus 7 So 11 is equal to negative 8a plus 4b plus 7. Getting the numbers onto one side, so minus 8a plus 4b is going to be equal to, take away the 7, it's going to give me 4, isn't it? Yeah, so 4. That's going to be equation number 2. Okay, so now considering the two equations, let's go and do it in green. We've got 12a take away 4b is 0, equation 1. Equation 2 is minus 8a plus 4b gives me 4, equation 2. If we add these together, the b's will cancel out, so let's go and do that. So it's going to give you 4a. 4a is equal to 4, so a must be equal to 1. And then to go and get b is put a back in, so put it back into equation 1 because why not? So 12 times by 1, take away 4b gives you 0. Therefore, minus 4b, take away that 12 will give you minus 12, so b must be equal to 3, I think. So a must be 1 and b must be 3, unless I've made a mistake. So question 17, a is 1, b is 3. Okay, good. Good. Question 16, you've got to solve this simultaneous equations. Right, what's going on here? So you've got two unknowns. Okay, so it's not like the one where you've got 3 unknowns in 1. Now, what am I thinking here? I am thinking, I've got 2x and a y, I've got x and a 3z, and I've got this. What I'm thinking to do is to make one of these two the subject and put it into the first equation. Now, I'm actually going to go on a second one, make x the subject and say that x is equal to 2, take away 3z, because then I can go and put this part here, this in for x, which will just leave me with unknowns of y and z, which will be useful because that's also just y and z down there. Let's go and do that. So putting it into equation 1, you're going to be getting 2 lots of x, where x is 2, take away 3z, plus y equals to 13. Now there's still going to be 2 unknowns here, but my unknowns are now z and y, which I've also got down here, and I can then eliminate these later. So let's work through this. So 2 times 2 is 4. Take away 6z is going to give me, plus y gives me 13. So it's going to write it as y, take away 6z, take away that 4 is going to give me 9. That's going to be, call it equation 1. Now, I've also got the equation down here. This one, I'm going to go and rewrite this one below this one with the minus 2y first of all. So we've got minus 2. In fact, that's just going to write it normally. We've got z, take away 2y equals to minus 7. Go and call that equation number 3. Now the thing is, I'm going to be comparing these two equations here. I want the same coefficients. I'm going to go and times this one actually through by 2. So I get a 2y here. I'm actually going to go and write the z first of all. So if I go and take equation 1 and times it by 2, that's going to go to minus 12z plus 2y being equal to 18. Now I can go and add these, okay, because then the y's will cancel out. So I'm going to be getting minus 11z is equal to, what's that going to go to? Crikey. 10, 11, minus 7. Oh, minus 7 add 18 is 11, which works out nicely, doesn't it? So z must be minus 1. Okay, so I found one of my variables. Z must be minus 1. Put it back into maybe any equation, this one up here, to go and get x. So x is going to be x is going to be equal to 2 times by 3 take away minus 1. You can choose any equation, that's going to give you 5, so x is going to be equal to 5. And then we go and find y by putting it into an equation that has y in it, so let's go and put it into this one. So you can choose though, but I'll go z, which is minus 1. So z, take away 2 lots of, z is minus 1, take away 2 lots of y equals to minus 7. So 2y is going to be equal to 6, so y is going to be equal to 3. So 5, 3 minus 1, I think. 5, 3 minus 1 is correct. Good. Okay, hopefully that made sense. What time am I on? Let's have a look. Okay, we'll keep going for it longer. Actually, should I stop here? How many questions have I got left? You know what? I'll stop here and we'll keep going. It's got really laggy. I'm not sure what's going on there. We'll stop here. Question number 19 next.